Okay, so if you remember from last lesson, finding the maximum, if you want to find a maximum, you go to second function, calculate, and you hit number 4 there. All right, and then it'll ask for left boundary, right boundary. You got to find the cursor. Okay, there's the cursor, and I got to go to the left of where that maximum would be. So we did this yesterday. You hit enter, and you go somewhere over there to the right of where the maximum would be, and you hit enter, and you hit enter again. So to find the maximum, that's what you do. The maximum is going to be, in this case, it's going to be 5. So for this one. So you want to take that y equals 5 is the max. Okay. And in this specific question that we're talking about, it's asking at what time does the projectile, or whatever it is, the ball, or whatever it is, at what time does it reach half its height? Okay. So this is the next part that I wanted to get to. So we want to know where, like what x values, okay, let's just get rid of that. What x value is associated with exactly half of this height? So what would be half of the maximum here? Half of the maximum is y equals 2.5. So you can't just type in y equals 2.5 in this. You can type in an x value and look for the y, but you can't type in a y. So this is what you have to do. You have to go to your y equals, and then you type in a horizontal line that represents half of that maximum. So I'm going to put in 2.5 here. Okay? Now if you graph that, this is what you have. You see that? So this line represents half of the maximum height. And now what we want to focus in on is finding what the x values are of this intersection now. So I'm just going to change that window a little bit again here. So let's go x max to 7. Let's go y max to 6. Okay, so here's a little bit better picture of it. So I want to find out the intersection points. And again, this is in the calculate menu. So we've talked about a value, 0, max, min. Now number 5 is intersect. Okay, so if you want to find an intersection point, you hit number 5. And then it'll ask you, is this the first curve that you want me to consider as far as the intersection goes? And you say yes. And then the cursor will flip to the other one, and it'll show you the equation at the top left. Is this the second curve? And you say yes. Now what you want to do is you want to find an intersection point. Now there's 2 here, right? There's 2. So move your cursor close to the intersection point that you want the calculator to find exactly. And then hit enter. And it will give you this exact intersection point. So why is this important? Well, this is the exact time, the first exact time, that this projectile reaches half of its maximum height. So this is 0.419, let's say. So at y equals 2.5, x equals 0.419. And so if this was meters, this would be seconds, let's say. And so that is time 1. And you would see that if this was a ball that was getting hit up in the air, it would reach half of its height at this time, but it would also reach half of its height coming back down. And so you do the same process for this other intersection point. So calculate, intersect, first curve. Okay, so it'll show it to you up there. Yes. Second curve. Yes. And now you want to move the cursor over to the other intersection point. Okay? So somewhere close to the other intersection point, hit enter, and there you have your next time that it reaches, 3.58. So that's how you use the intersect function.